This is a new high voltage probe I'm working on. You can see here this is the tip connector. These are two super Mach resistors. These resistors are 10 watts each and they're rated for 45,000 volts apiece. At the rated power dissipation, these resistors have a life of about 2,000 hours. We can see in the end here, this is a Evercharles pogo pin. This is a needle type, that's what I plan on using. This is a end cap, Teflon tube spacer, and this is a section of phenolic tube. The phenolic tube will be used to encase the two resistors, and this will act as the dielectric for the high frequency capacitor. You can see some corona dope. This will be used to dope these different junctions. This assembly just slides into the end like so. The pin here fits into the end like this. The pogo pin then inserts into the end like so. The Teflon spacer and fits into the end like this, and then the end cap goes over the top of this. The outside of the phenolic tube then will have our other plates for our capacitor. These will be soldered to the brass end. The assembly then will then get encased inside of another insulator, and then there will be a shield that will encase that. And then on the back side of this will be the probe compensation network, and this will go off to another piece of coax, will then go down to our oscilloscope. My goal for this is to use it with about 40,000 volts DC, or about 80,000 volts at 50% duty cycle. Basically, I want to keep the power dissipation and the resistors down. I'm hoping here I can achieve about 50 megahertz with this probe. See, I've gone ahead and doped this junction. I'll end up coating this a few more times. Once I'm sure that that's completely sealed, we'll go ahead and install this thing into the tube and we'll run some tests on it. I've layered up 3 coats of dope on the 2 Mach resistors. You can see I've gone ahead and cleaned out the bore, also cleaned up the rest of the Teflon parts. With the higher voltages, parts will have to be cleaned quite well. You can see here there's a small piece of silicon on the end of this, down to the Teflon, and the back cap where it's been soldered. The end cap here just fits over the top. The next step will be to connect some outside conductor for the secondary plate of the capacitor, and we'll run some tests on this to see what kind of frequency response we can get with this. I'm not sure with the thickness of the phenolic tube what kind of response we're going to get. So as long as it looks like we can compensate a piece of coax, I think we're probably good to go with this piece, and then we'll start focusing on the rest of the case. A few months ago I had made a set of probes. I designed these probes to work up to about 2,000 volts. After making them, I ran them up a little over 4,000 volts, not had any problems with them. I'd like to be able to go up a little higher. I have a P6013 Tektronix probe. That's good to about 12,000 volts. I'd like to make a probe that would go to about 40,000 volts. So this is the initial attempt at it. This piece of magnet wire is making up the capacitor. The phenolic tube is the dielectric for the capacitor. So currently I just have a piece of coax attached to the oscilloscope. You can see here I'm using the old LaCroix scope. So just with this piece of magnet wire running down the length of it here, I thought what we would do is see what kind of roll off we get with this. This is looking at the signal with a 1 Hertz input. Here we are at 10 Hertz. Here we are at 100 Hertz. This is at 5 kilohertz. Ten kilohertz. Here's 100 kilohertz. This is 1 megahertz. Here's 10 megahertz. And this is 15 megahertz. So it definitely looks promising for a piece of wire that's just kind of wrapped around it right now. I have to make a few more parts for this thing, and then we can go ahead and mount this thing in some kind of a case and start adding the compensation network to the back side of this, and we'll see how well this thing will actually work.